Here's a situation that's a little bit different than what we've been working with. The first question says, a ball rolling down a ramp has a constant acceleration of 3.0 meters per second squared, or 3.0 meters per second per second. What is the velocity of the ball after rolling for 4.30 seconds? Now, when we look at this problem and we start identifying the variables in the problem, we are given the acceleration right here, 3.0 meters per second squared. It says, what is the velocity of the ball after rolling 4.30 seconds? So that's a time, 4.30 seconds. What is the velocity? Well, really what we're looking for is the ending or final velocity of this ball after accelerating for 4.30 seconds at 3.0 meters per second squared. So we're looking for the final velocity, or V sub f. So here's how we solve this. We have to take this equation, acceleration equals V sub f minus V sub I divided by t, and we're going to rearrange it and solve for the final velocity, V sub f, because that's what we're looking for in this problem. It says, what is the velocity? I could have said, what is the final velocity of the ball after rolling for 4.30 seconds? We're looking for the final velocity here. So we're going to use some basic algebra and rearrange this equation, and we need a new equation here that says V sub f equals. So this is how we're going to do it. The first thing we have to do is get rid of the time down here below this division line. So opposite of division is multiplication, so I'm going to multiply this by time. That means I also have to multiply this left side of the equation by time. And that cancels out the time right there. That gets rid of that. Okay, so now this is what our equation says. Our equation now says time times acceleration equals final velocity minus initial velocity. So now we want to get rid of the initial velocity here and just leave final velocity, because we're going to be looking for the final velocity. So the opposite of subtraction is addition, so I'm going to add the initial velocity to this, just like that, and I'm going to add the initial velocity over here, right there. So what does that do? Well, it gets rid of the initial velocity there. And our new equation says, watch this, final velocity, V sub f, is equal to acceleration times time plus initial velocity. And that's the equation that you see right here. That's that equation. This equation says the final velocity is equal to the initial velocity plus the acceleration times the time. So if you know the acceleration of an object and you know how long it's accelerating for, you can calculate the final velocity of the object. So let's go ahead and do that. Now we know we're looking for the final velocity down here in question 1. So we're going to use this equation. Final velocity, V sub f, is equal to the initial velocity plus acceleration times time, just like that. Now we can plug some numbers in here and we'll see how this works. Final velocity is equal to the initial velocity. Well, in this problem, the initial velocity isn't given, so we're assuming that it's 0. So I'll say 0 meters per second plus the acceleration. And the acceleration you can see right here, 3.0 meters per second squared. And we're going to multiply that by the time. And the time is 4.30 seconds. And when we work this out, we're going to have a final velocity of 12.9 meters per second. Now you might ask yourself, why does it work out to meters per second? Well, watch what happens right here. Here we have meters per second squared, and the seconds squared, it literally means meters per seconds times seconds. So meters per second squared, if we see this second is above a division line and this one's below a division line, so it actually gets rid of that. Think about that for a minute. We got rid of the seconds squared and now it's just seconds. So this works out to meters per second, which is in fact a velocity unit, and that is the unit in our answer, and that's the unit that comes down there. So the answer here is 12.9 meters per second. All right, now let's go down here to this next problem. It's basically the same problem. We have a car traveling at 14 kilometers per hour. So at the beginning of the story, initially the car is traveling 14 kilometers per hour. So you can identify that as the initial velocity, V sub I. Now, when you're working problems like this, it's very important that you read the problem carefully, think about what's happening in the story, in the problem, and be able to identify the variables properly. A car traveling at 14 kilometers per hour. So that is the initial velocity, the beginning velocity. Accelerates at a constant rate of 2.8 kilometers per hour per second. So that's going to be our acceleration. And the time is 8.0 seconds. So we label that in the problem. Now we have an acceleration, we have a time, and we have an initial velocity, and we're looking for the final velocity, and that's V sub F. That's what we're looking for. There's a question mark there. So we need an equation that says V sub F equals final velocity equals what? Well, final velocity, according to our equation, is initial velocity, V sub I, plus acceleration times time. Just like that. So now we plug numbers in here. So we V sub F is equal to the initial velocity, which is 14 kilometers per hour, plus the acceleration, and the acceleration is 2.8 kilometers per hour per second, and we're going to multiply that by the time, which is 8.0 seconds. And when we work this out, we multiply 2.8 times 8, find that answer, and then we add 14 kilometers per hour to it, and we get a final velocity of 36.4, and that's kilometers per hour. Why is it kilometers per hour? Well, again, watch what happens. Here's the second below the division line. There's a division line. Right there is a division line. So we have kilometers per hour per second times 8.0 seconds. So that factors out. That cancels out. So our answer is 36.4 kilometers per hour. So here's a situation, two problems, where you're looking for the final velocity, and you're given the initial velocity, the acceleration, and the time. Well, here's a practice problem for you. It says a train with an initial velocity of 4.5 meters per second begins to accelerate at 2.0 meters per second squared. What is the train's final velocity after 8.0 seconds? So what I'd like you to do is pause the video, answer the question, then turn the video back on, and we'll go over this problem together. So go ahead and pause the video now. Alright, let's go ahead and solve this problem. The question says a train with an initial velocity of 4.5 meters per second. Obviously that is the initial velocity, so we can label that V sub I. Begins to accelerate at 2.0 meters per second squared. Now this says that it's an acceleration, but you also recognize that this is an acceleration because it says 2.0 meters per second squared, which means 2.0 meters per second, and that is a unit of acceleration. And so we're going to label that acceleration A. It says what is the train's final velocity? So we're looking for the final velocity, or V sub F. I'll put a question mark after that just so we know that that's what we're looking for. And we're also given a time T, 8.0 seconds. So obviously with the information we have here, since we're looking for final velocity, we need to set the equation up. V sub F equals, and the equation we're going to use is initial velocity plus acceleration times time. Just like that. Now go ahead and plug some numbers and units in it, and it looks like this. Final velocity is equal to the initial velocity, and that is 4.5 meters per second, our initial velocity, plus the acceleration, and the acceleration is 2.0 meters per second, or meters per second squared. We're going to multiply that by the time, 8.0 seconds, and when we work this out, we get 20.5 meters per second. So the final velocity of the train is 20.5 meters per second. And it's always a good idea to double check the unit in the answer and make sure it matches what you're looking for. You're looking for a velocity unit, and so we see that that cancels out, that cancels out, and the unit here is meters per second, and that's the unit that comes down into the answer. That is the derived unit in the answer. So there's the answer to the practice problem. Hopefully you got that right.